example, in basic electrical and electronic engineering, let us see bipolar junction transistor, commonly called BJT. Overview in this PowerPoint presentation, let us see overview and introduction of BJT, structural design, functionality, and mechanism, different types of connection, method of testing transistors, practical uses and application. Introduction. In this features features three terminals known as bipolar junction transistor. The BJT developed in 1930 at the telephone laboratory. It marked the beginning of a revolutionary phase in the solid-state electronics. Eventually, the MOSFET took over as the dominant transistor in the contemporary electronic devices. Semiconductor devices form the foundation of modern electronic system. Among these, bipolar junction transistors are widely recognized and extensively utilized. BJT serves dual roles. They perform as amplifiers and as switches in logic circuits. Each BJT features three terminals. One is collector, base, and collector. Collector, base, and emitter. BJTs come in two varieties, PNP and NPN types, each with distinct characteristics. Device architecture and how it works. The distribution depicts a basic layout of a dipolar junction transistor. It is made by three distinct semiconductor zones. The emitter, which dropped with N-type material, the base, composed of P-type material, the collector also emitter. The configuration is known as NPN transistor. There is also an alternative arrangement called PNP transistor. So this is the pictorial representation and this is a symbol of BJT, which are base, collector and emitter. So base with N, emitter with P, collector with P. This is PNP and the symbol is as shown. Overview of the transistor is it consists of three semiconductor layers arranged in the specific sequence and NPN transistor feature a P-type layer nestled between two N-type layers and PNP transistor are N-type layer positioned between two P-type layers. The term bipolar refers to the involvement of both electronic antipodes in moving charges across the regions with opposite electrical polarity. Each being junction can be biased in two ways. One is forward bias, another one is reverse bias. As a result, a transistor with two p-n junctions can be subjected to four distinct biasing conditions. Layout of terminals and BJT representation. The base terminals is centrally situated and is distinctly slimmer than both collector and the emitter. The emitter and collector share the same type of semiconductor materials in contrast to the base, which is made from a different semiconductor variety. This is a symbolic representation of PNP and NPN transistors. Transistors current. The emitter terminal is always marked with a low marked with an arrow. This arrow consistently points towards the N-type semiconductor region. Arrows directly represent the flow of current to the emitter. For PNP transistor, the current flow from the emitter to base. For NPN transistor, the current flows from base to emitter. The key current involves collector current, base current, and emitter current. How the transistor works. The fundamental behavior using PNP transistor is as our example. The PNP transistor functions mirrors that of an NPN transistor if you swap the role of electrons and holes. Within the transistor, one PNP junction is set to allow current flow, forward bias, while the other junction is configured with a block reverse bias. Forward bias junction is an PNP transistor and reverse bias junction is an NPN transistor. That is also in this figure the forward bias junction of CNT transistor, and this is the reverse bias of junction NPN transistor. And NPN transistor are subjected to both biasing potentials, illustrating the movement of majority and minority charge carriers. Positive majority carriers diffuse through a forward bias PN junction into N-type region. Only a tiny fraction of these positive carriers tra- transverse traverse the N-type area to reach bias terminal, producing the base current typically measured in microamps. Meanwhile, a substantial number of majority carriers across the reverse bias junction entering the N-type material link to the collector terminal. Majority charge carriers are able to traverse the reverse bias junction because once injected, they behave like a minority carriers within N-type semiconductor. Applying Kirchhoff's current law to the transistor in I equal IC plus IB. The collector current IC consists of two parts, the flow of majority carriers and flow of minority carriers. The component IC, the component IC minority also known as ICO represent the leakage current measured when the emitter terminal is left open. These are the reference book